Hey guys, and welcome to the third video in the Entity Framework Core, the most definitive course on Entity Framework Core and .NET that you are going to see. So in this video, what we are going to do is to set up the base project, which is like a base framework that you are going to use across your API or any other projects. So we shall be seeing how we can define the project, how we can split the files, rather position the files physically in different projects, and so we shall be taking care of the repository and a very basic unit of work pattern, and like what advantages do we get in this particular scenario. We will be seeing all these areas, and the way we are going to position these files, build up the framework, is that it supports all these solid principles, clean code, and other patterns around that. So without wasting any time, let's quickly dive in. And as I say, if you are coming here for the first time, subscribe to our channel and hit the bell icon, because there are amazing videos coming down the line on Entity Framework, and we are structuring these videos and tutorials more towards the production and enterprise software development, how they are actually going to be used. So let's start. So right now we are on step one, which is basically the startup and the ramp up, where we are setting up the tools and the base code that is required to go on the more advanced and further use cases. We have so far covered up the quick start and introduction, which is the module one, where we have seen how we can add entity framework code in command line project or console project basically. The next module that we covered up is like why entity framework, where and why it is used, and why it is one of the best frameworks for DAL layer, especially in the .NET world. And right now we are at design infra for production, which is module 3. And this module intends to give you a brief understanding on how you can better place and position your files and structure your projects. So again, the target is to get more streamlined and abstracted projects, so that things look better when you go into production. The code is maintainable, even if you scale it out many folds. So far, I have seen multiple implementations across multiple projects, and what people do is like they tend to mix up each and everything, all of these areas, entities, and everything in single project. And it's not wrong actually, but as the time proceeds and as the solution evolves out, what happens is most of the time it is very difficult to maintain and manage this code base. So we would be looking at how we can structurize our code base, so that let's say if there are more entities, or let's say even if we have to change the complete database engine, maybe from MySQL to SQL Server or to a Postgres, it should not actually hamper any of the code base and the business logic. So we will be looking at these areas in this particular module. The next sub area that we shall be looking in this particular module is like how to use those in a REST or a web API project. So guys, before we actually start with the project, a very quick request: don't skip any of the sections of this video, along with the very basics and important patterns that we'll be looking at, including the repository and unit of work, which are like the basics and will help you out a lot down the line. We would be looking at some of the major columns, like if you want to have a common columns in a particular table, how we can have those functionality. And as I mentioned, like some of these areas are very much from the experience that have come down the line of using Entity Framework Core. All right, all the code base that you are looking at, that we will be looking in this video, is available on GitHub. The link is in the description. You can download the code and use it in your project as required. It's pretty much open. You can use this as a baseline for your project, or maybe like you can just take references and do your own implementation. It doesn't matter. Now, one more point, I have tried to split the complete code base that you are looking at, the DAL layer, across multiple projects. It's up to you, again, how you are going to implement it. Ideally, we should have these split up so that they can be separately managed, updated as required. Let's say for whatever reasons, if you want to combine them or use them, it's up to you. That can be completely managed as required. So you can split it further or can combine and merge them. That should be perfectly fine. So guys, if you are coming here for the first time, I'll request you to subscribe to the channel and press the bell icon, because as you can see on the screen around migrations, configurations, how to do for productions, and there are a lot of advanced topics which probably you will not find anywhere else. We will try to cover those as well. So press the subscribe button and hit the bell icon so that you get notified instantly. Alright, so what we have over here is an empty solution just as we created in our first module. If you have not seen the first module, you can go, the link is showing on in the info bar above and in the description as well. So you can go over there. And this is basically a bland solution, and what we are looking at is an sort of an HRMS application. And in this module we shall be creating all the baseline files and structure that is required in a more patterned way. Down the line we will add on further functionalities. So we shall be looking at two tables. One table sort of act as a master data for user roles. So a user may be a developer, he may be a tester, he may be a manager. So all those sort of things are covered in the user roles table, or user profile rather. And the other thing is the user. So that is very much similar to what we have created in the first first module. So you can quickly go that, or rather we would be covering those here as well. So that is the first thing that we should try to do, is to keep our entities, the core entities, as clean as possible and as separate as possible. And the idea being, if they are very much cleaner, we can always reuse those entities anywhere else without any of the framework dependencies, framework overheads as we progress. So let me just quickly add a project for my entities. And the idea being, again, this entities project, it should have only the POCO classes, the plain old C# objects, those classes over here, without any further functionality. So I'll add a class library for .NET Core, as you see over here. So we can go with the class library .NET Standard as well. But for simplicity, in this module, we shall be using .NET Core. Alright, so I'll add that, and to name the project, I will simply call it hrms.dal.contracts. And again, the idea is it should be as clean and simple as possible. Alright, the project is loaded, and if you see over here, we have a default class. I'll just delete that, and I quickly add a folder called entities. Alright, so all my entities will reside in this particular folder, and let's quickly add a new class and let's call it user. Okay, let's add a few properties over here. Alright, so these are basically the same properties that we added in the previous module. And I'll quickly add one more class for my roles. Alright, so before we move forward, a few conventions that we should generally follow. First thing is, whatever the class or an object it represents, it's a singular object. So we should not be having any pluralized names over here. So it should always be user role and not user roles. So it should not be something like this, but it should rather be just user role. And the other thing is, one of the very common conventions that we generally follow is that we, for the primary key, we just use the name of the table followed by the ID. So in this case, it would be user role ID, because the table name is user role, so it would be user role ID. And likewise, if we see over here, for the user, we have the user ID. So if we use this way, if they use this convention, like the table name followed by the ID, EFCore automatically picks it up and it identifies, okay, this is the primary key. We need not define it. Although it's still better, we do that, but it's not mandatory. Now, one other thing we can do is we can do something like this as well. And this will also be covered. So if there is a property called ID in this particular format, the framework automatically captures that as well. So these are like some of the built-in conventions we already have in our application. Now, when we see enterprise software, there are a few things that we need to take care of. and one of them is like we need to maintain the audit records. It's like who created the record at what time, and let's say if the record is being modified, then who modified it and at what time. So there are a few properties or columns that we need to add. So something like this. Alright, so we have added these four properties over here, and they basically represent who created this record at what time, and likewise when it was modified by whom. Alright, so one very quick question that comes straight to mind is why is this a string? So this refers to a user, it should be an int. Well, in many scenarios, there can be certain cases where it is being updated by some machine or some system ID and not by the actual users. So it's more of a actor's design pattern, which is outside the scope of this video, but very quickly to cover that is basically the actor or basically the person or instance that is updating these fields or these records. That might not be the end user in all cases, but rather it could be something like a machine or some other service. It could be anything. So if we are using, let's say, a service to service communication, that would be using client credentials flow, which doesn't have a user ID, but rather have a client ID. So to cover all those cases, it's ideally preferred if we use some sort of a string over here. All right. So the other thing that we see over here is created on and modified on. Right now we have presented with a date time, and there is a problem with this particular type. So I'll give an instance. For example, let's say if the record is being updated or created in India at, let's say, 4 or 4 a.m. and sometime I try to view that in US. At that point of time, it will be an MBGS. It will just give it's created on 4 or 4 a.m. But regardless, so that absolute time would be different in India and US, but system will not be able to differentiate that. To solve that problem, basically what we do is we add the offset field over here, and what it does, it basically captures the date and time along with the time zone information as well. The other workaround could be like we can use the day, UTC time within the date time field. But there are certain challenges, and the problem is like it becomes the responsibility of the code whenever you are setting or creating a new records. Like, okay, this is my date time, convert it to UTC and then send it, which can be missed out by certain developers. So the ideal way of doing that is to use the date time offsets, so which is always a relative time zone. It can have a time zone of US or UK or India, but the actual time will remain same regardless of the position. All right, so if you see now, basically we would be having these sort of four columns in each and every table, probably in each and every table, and that gives a new problem. Should we write it every time? And the ideal way of doing that is like we add a base entity over here or a base class, and we move all the common properties that we need in the base entity or a base class. So I'll quickly add a base entity, and let me just move all these four properties from here to here. And additionally, we can create this class as abstract class so that it cannot be directly inherited, and that was fine. Now what we can do is simply we can inherit from this class and it will work fine. And likewise over here, perfect. So this covers our entity part. We have created our entities right over here. So this base entity that you see over here, it serves two purposes. Part one, any of the common properties that we need to have across all the tables, any columns, if we speak in SQL terms. So all those we can define over here, part one. Second thing, what we can do is, let's say if we want to use it as a marker as in like we will be shortly seeing that. Let's say if we are building some generic classes where we want to have a sort of a generic interfaces, we can use this as a generic type constraint. So it can be used there as well. All right, so we are covered with the contracts or the entities. Now let's quickly add one more project which will be our actual DAL project as well. And the steps and the process remain same. We add a new project. We select a class library for .NET Core. We press next. I will call it hrms.dal for this project, and we will create. Let's minimize this and delete the extra class. We don't need that. Alright, so we have our DAL project, and the first thing that we need to do is to add the Entity Framework core package. And how we do that? We go to manage new packages. It will open the window. We go to browse. We select Entity Framework. It will give a list of packages. We select the Entity Framework core. Now, one very quick point, I am not selecting the Entity Framework core.SQL server package the way we did that in the first part. This project relies mostly on the base package, which is the Entity Framework core, and it will contain all the functionalities including querying, updating, schema tracking and everything within that. So the SQL package that we see over here, that will be referred from the invocation project. Invocation as in the project where we will be actually calling and configuring the database. And one very immediate benefit that we receive from that is that our DAL project is not dependent on any of the relational engine, for example SQL Server. If we want to add, let's say, MySQL or SQLite, we can just change that from the invocation project, and that will work as it is without any challenges or problems. So let's quickly accept it and add that. Alright, so let's quickly add our first class, which is going to be DbContext. And as I mentioned previously as well, the one of the better ways of doing that is to always use sort of a convention. Whatever your DbContext it is, just suffix the name with a DbContext. So that helps in identifying that this is a DbContext. It's not of a mandatory thing, but more of a general coding practices or convention that we generally follow. So I'll make this as let's call it, let's do it internal for now. And again, the same way as we did it in the first module, we will add a prop db set of type user. Now we need to reference these projects as well. So that is probably the reason. Let me quickly add a project reference. Come on. All right. And the next convention point is when we add over here, at this point always pluralize. So if it's a user, always say users. So that gives a pretty much better view. The reason being, whenever we add or query from this, it gives a pluralize or a collection of the object. So we do it that way. And likewise, I'll add quickly for the other. And likewise, we have user roles. Now, once we have these, we need to derive it from DbContext, which acts as a base class and glues everything together. Now, a few more things that we will cover. So basically, we are done. So DbContext is pretty much what we need in terms of the base classes. And we will add a quick implementation for unit of work that gives us basically the control when we actually fire the changes, and it gives us an interception point as well if we want to, let's say, update something before the data is being committed into database. Now there are other approaches for that as well. For example, there are trigger implementations which we shall be looking at in the advanced roles. But for a very simple interception, if we want to look at, we can cover those over here. One pretty good use case scenario for that is, let's say if you want to have a sort of a soft delete based functionality. So from the application or from the business logic, you will fire a hard delete, but you want to convert that hard delete into a soft delete. So that can be covered here. So we can do that from the unit of work interception. And the other thing that we can do is something like, let's say if you want to have the records being tracked into an audit table, so all those cases can be covered with this pattern. So let's quickly add that. All right, so we have our Barebone implementation for save changes in the unit of worth. And what we have done is we have our class unit of worth class over here, and we have an interface that is defined over here. Now, this interface has two methods, save changes and save changes async, depending upon what pattern you are following. So async patterns and async calls are like very much supported by Entity Framework. In fact, they are preferred, although there are some challenges on how the EF actually communicates with the database engine. So there are certain limitations. It cannot do cross queries. For example, let's say if one query is running and you try to execute another query, so those things cannot be done. There are some challenges around that. But again, it supports like doing that asynchronously. And with EFCits, there are certain benefits, more features such as streaming, or those things are also coming in. We shall cover that in a separate part. Yeah, but again, so we have a Barebone implementation. We fire the save changes on the DbContext with this, and if the result is more than 0, it basically returns a true or a false on that. And likewise, we have a async implementation for this. It basically takes a default parameter over here, and if the based on that, if the result is more than 0, it returns as true. So if you want to, let's say, cover some of those interception points, you can do that over here. For example, so I can have something like this, and then implementing that, what we can do is we can cover all the interceptions or cases that we want to cover. We can cover over here. And basically for the injection part, we are injecting the instance of the DbContext that comes in. So that's pretty much over here. One more one more class that we will quickly cover before we move to the next module, where we will actually bootstrap this. And not one, actually two areas would be the repository and the extension methods. So let's quickly cover that as well. So I'll quickly add those classes, and then let's have a breakup on what and why we are doing that. All right, so what we have over here is a base repository class, and the purpose is, again, there are two purposes. One is like if you want to have some interception or markers, we can do that. And the other thing is like we can try to encapsulate some of the base or common functionality that we might need across all the repositories within this class. And the important thing to note over here is like it's a generic class, and the constraint that is passed in is as a base entity. Any of the derivations of the base entity can be passed in over here. And the way we generally use this, let me quickly add a user repository, and again we will restructure it in a folder. But let's say we have a repository. So what we can simply do is we can do something like base repository, and it's have a implementation for user, and that way it will work around. This we will mark as internal. Let me add an object here for repositories, and we have the repository implementations. Let me move the user repository implementation and update the namespace. Perfect. And now I need to have an interface for this. I'll just click extract interface, user repository, and this I will move my over here. So if you see over here, we have kept the implementation for user repository as internal. while the interface that we have over here is marked as public. So this prevents any of the unintended changes being exposed out, and all the communications that happen between the layers, between the classes, that happens via the interface only, nothing outside of it. So that's why we limit that. So let's say if there is one more business project over here or the invitation project, so what will happen is basically they will all use these interfaces and not any of the repository. And let me move these over here as well. And what I do, I'll set this to not add a namespace, and I need to fix this. Which one? This one I need to fix. All right. Now we are good. And the idea is infrastructure is a sort of a logical layer where we are putting the code content, but actually should not be a separate namespace component, and that's why we have done that. All right, so now we have our okay. Let's quickly add the implementation for the base repository as well. So the first thing that we need to have is a exposing field for our base repository or the collection. So that is pretty much easy. We just add a db set of type t, and let's call it just db set, and we will put it as a protected one. Next, in this constructor, of course, we need to have the HRMS DB context over here, and we can initialize the DB set as HRMS context dot set type T, and we need to change it to protected. Perfect. Why it's giving the error inconsistence? All right, we might need to change it to internal, and this should work out. Yes, pretty much. And I'll quickly add two methods over here. One is if I want to find any of the objects, so that is pretty simple. I'll do this, and within the db set dot find, and if you see over here, I need to pass in as my primary key. Now the trick over here, if you are let's say if you are sure you are having the primary keys of only one type, let's call it int or string or droid or whatever it is, you can pass in that. For example, in our case it can be an int and followed by something like this, and we can just use it something like this, and it will work out. But there is a problem. Let's say if you are having a mixed environment where in some of the tables it's an int, and some of the tables let's call it let's say it's a GUID or a string. In that case, you would rather need to use an object over here of type object. All right, I think we are good with that, and just one more method before we move. Let's call it add. So if we want to send in an entity of type T, it should be added, and that's pretty much straightforward. Okay. All right, one piece of warning over here. So if you go over here, if you see there are two methods, add and add async. While add, we should not be using add async method. It is used by the entity framework, and from the code it should not be used because it fires a commit internally. If you see over here, it mentions as well for all other cases non-async method should be used. So it defines these cases, and if we use add, it basically provides the state tracking and all those sort of things. And again, within our unit of work file over here, we can, let's say if we want to do some changes, we can do that. All right, it's giving me a warning. Let me quickly do that, and we will pull these. So let's have an interface as well for this class, and we will do, let's in its own class select public, we'll press next, and it's done. All right, we have this, and one more thing that we need to do is we need to pass this. So we have, do we have an interface for this? Yes. Let's fix the namespace and let's add that T over here as well. So guys, adding these constraints, the generic constraints, it's pretty much helpful. It might look like an overhead right now, but as you move forward, you will see like it has a lot of benefits down the line. All right, so we have defined that if we have created an internal interface, or we can create this public. So let's call it this is a public interface. And again, I think we need to move the base repository this as public as well. Anyways, these are interfaces, should not be a problem. Let's do a quick build and see like if there are any problems with the code. I guess it should not be, but yes, there are a few. Let's quickly resolve these. So this was a reference error, and we have one. Okay, we need to have this implement. We need to pass the type of the object, and we need to add the missing implement, and we need to add the implementations. That looks fine. All right, it should pass now. Let's quickly validate. Okay, so we are done with most of the part. The only thing that is left from the infrastructure point is the extension methods. So we need to create a few extension methods, and those would be responsible, let's say if we want to register these repositories. So we would be controlling all the aspects of the registrations within this project. Let's say we have these interfaces as public and the implementations as internal. So those registrations can be taken care within these extension methods. And the convention that we generally follow for naming these extension methods or these classes, it's like we segregate the extension methods based on the type they're extending in separate classes. And for the name of the file, we just put the name of the type followed by the extensions. So in this case, we will be extending the service selection extensions. So we will just put it like this. And add in the extension implementations. Alright, so I have created two methods. One is for registering all the repositories, and in this case, let's say if we have services dot add scoped, and I'll add the user repository that we have just created. And likewise for the unit of work, we will just add something like this. Alright guys, we are done for this part, and if you see like we have successfully created all the base classes, the framework, and we have also maintained the access modifier for these. For example, let's say if a class needs to be internal, the implementation needs to be internal, we have created that, and we have successfully created the extension methods for registering those against the public interfaces as well. So all the abstraction, all the layering, whatever I want to do, so all that happens on the basis of my interfaces, and I can straight away work with my classes which are internal without knowing the implementation. Alright, one quick thing, I made a mistake, let me correct that. We do not need the generic constraint within the user repository at this layer. So basically what we can do is we can go over here, we can remove this T, we can remove this, and over here we can just pass in the user, and that will work. So we don't need to repeat this at the implementation, and my implementation remains clean. And now it is giving me some error. Let me quickly see. Okay, I need to go over here and remove this as well. Perfect. Fits. And one more thing quickly is I need to go over here, and okay, this is perfect. So that's pretty much guys. The next video we will be using this framework project in our actual
implementation. We will be bootstrapping the web API project based on this.
So guys, I hope you liked the video. We have just seen how we can start building our framework. There is not much of the execution part in this particular video, but down the line from next video onwards, next tutorial onwards, we shall be seeing how we can apply these concepts and actually use this further. So before we conclude, if you have any queries, suggestions, any problem, anywhere you're stuck, just let us know via comment section and we shall try to solve it as soon as possible. Just let us know whatever your concern, and if you like the video, if it is helpful in any case, just hit the bell icon. It keeps us motivated and let the ball rolling. And the code and lastly, before ending this video, the code is available in the GitHub. You can reference it, you can baseline it, do whatever you want to do. Thanks for watching. Have a great day. See you.